All right, let's go ahead and take a look at a proof. So what we are given here is that line PS is the perpendicular bisector of segment RT at S. So point S is right here. That right there is the point where you have the perpendicular bisector, which is PS right here. And that is line PS. And that line PS is the perpendicular bisector of segment RT. So that's kind of the information that we have there. And then what we are trying to prove is that segment RP, so this piece right here, is going to be equal to segment TP. So it kind of looks like that from the picture, but in math, we can't just assume, we have to be able to prove it. So first thing that we always want to do when we do a proof is write down the given information. So the given information is that we have line PS is the perpendicular bisector of segment RT at point S. So that's kind of the first thing that we have. And so anytime that we do a two-column proof, I always want to put the given information on that first line. Sometimes we break it down if we've got a lot of stuff. Sometimes we might put it on multiple lines, but we have that there. Then the reason for that is just that it's given to us. There's nothing more that we have to say. It's given information. It's something that's being provided to you. And then we're going to take that and we're going to try to prove RP is equal to TP. So you always want to put what you're trying to prove on the very last line as well in that statement. We don't have the reason just yet, but in this proof, all of those things are given to us. So we have started our proof there. So let's go ahead and we're going to dive into what we're dealing with here. So first thing that we have is that we have a perpendicular bisector. Well, first thing that we might want to take a look at is what's the definition of a perpendicular bisector? Well, that's just when you have something that is going to be perpendicular to another piece. So we would say that PS is perpendicular, that's what that little upside down T means, to segment RT. So that's all that that's saying. So perpendicular bisector, definition of it just means that we have that those two things are perpendicular to each other. And so from there, you can kind of see that's what we've got for the reason right there. Now, the next line, the reason that they give you is the definition of perpendicular lines. Well, when we're talking about lines that are perpendicular to each other, there's a couple of things that we can conclude from it. The big thing, though, that we can conclude is that we have two right angles. And so when we look at this right here, you can kind of see in this picture, you're going to see this little box right here. And so we would have that this angle here is going to be a right angle, and we'd also have that that angle there is a right angle. So that's kind of the next thing that we can conclude and show in this proof. So I'm going to go ahead and say that angle RSP is a right angle. So let me erase that there. So is a right angle. And so that's the first one. And then I can also say the other angle there is as well. So you can kind of put like a little colon there or something, and then you can say that angle TSP is a right angle as well. So those are both things that we can conclude from the definition of perpendicular lines. So we've got that information there. You could put that on two lines if you wanted to, but all of that's fine. You can just kind of keep that right there. Okay. So now the next thing that we have is that angle RSP is congruent to angle TSP. Well, when we look at that right there, what we could do is we could say that those two angles are going to be congruent to each other. The reason why we can say that they're congruent to each other is there's actually a special theorem called the right angle congruence theorem. So the right angle congruence theorem, So the right angle congruence theorem, and all that theorem is really saying is just that any right angles that we have are going to be congruent to each other. So that's what you have there. Next thing that we can do, and that's kind of wrapping up that part there. So if we go back to the bisector part at point S, we know point S is going to be the midpoint of RT. And that's just, again, the definition of a perpendicular bisector. So that's kind of the other part of it. So lines 2 through 4 is kind of one part with that definition. And now we jump down to line 5 with the other part of that definition of a perpendicular bisector. So we've got that information there. Well, if we know that S is a midpoint, then we know that it splits it into two equal pieces. So we would say that RS is going to be congruent to ST or TS. And so we can say that because that's the definition of a midpoint. It splits it into two congruent pieces. So we have that there. Now, The next thing that we have going on there is that we have that PS is going to be congruent to PS. That's going to be something that we're able to say. Remember, anytime that you have something that's repeated, so PS and PS is the same thing, we would say that's just the reflexive property of congruence. So reflexive property of congruence. And what allows us to say that? Well, if you look at the picture here, so if we just kind of look back at this picture, we've got this right triangle right here, and then we have this right triangle right here. Since we know that we've got two right triangles going on because we've got that angle, and we know that both of these are right angles, we know that they share this side. And since they share that side, it's basically saying PS in triangle 1 is congruent to PS in triangle 2. So that's what allows us to say via the reflexive property of congruence that those two things are going to be congruent to each other. Okay, so we've got that there. And so now that we have that information, we can say that RSP, so this triangle RSP, so let's pop this back. So this is triangle RSP. That triangle is going to be congruent to triangle TSP. And we're able to say that because of the side angle side congruence theorem. We just got done saying those two things are the same. And then they share side PS. And so since we have that, we know that that's going to be congruent. And then they have this included angle right there. So you could say side angle side congruence theorem. Another one you could technically use there is you could use leg, because this right here is a leg of a right triangle, and that's congruent to that one there. And then you could also say that this right here is leg number 2. And so since we have that both of those are legs as well, then we could use that too. And so that's what we have there. And so now the last blank that we need to fill in is we have CPCTC as the reason. That's corresponding parts of congruent triangles. That's just saying if we have congruent triangles, then we know that we have got congruent parts, or correspond, like the parts are going to be the same. And so again, if we're looking at this, the big thing that we're trying to prove here is we're trying to prove RP and TP are the same. Well, if we know those triangles are congruent, we know that those two things are going to be the same. And so we would go ahead and we would say that RP is congruent to TP. And that's because those are corresponding parts in congruent triangles, and so we know they're congruent. So that's how CPCTC will help us. Which, then now we know if they're congruent, that means they're equal to each other, because that's the definition of congruent segments. Hopefully that helped. I know it's kind of a lengthy proof, but hopefully that helped and kind of gave you a little bit of an idea on how to approach a proof with perpendicular bisectors in a triangle.